Hi student, so today we continue topic 4 for week 13. Topic 4, soil compaction and consolidation. However, for this week 13, we just focus on the consolidation. As usual, we go to program outcomes. There are two program outcomes, PO1 and also PO2. Cost outcomes, we have CO1 and also CO2, and then we also have COPO mapping, CO1 to PO1, CO2 to PO2. So for learning outcomes, at the end of this lecture, students should be able to understand, first, to understand the theory of consolidation. Number 2, understand the laboratory procedure of one-dimensional consolidation test, or known as odometer test. And last one, understand the soil stabilization method using preloading and vertical drains. Now, we start our consolidation topics. So what is the consolidation? Consolidation is the compression of soil under steady pressure due to expulsion of water from the void. So consolidation is quite different if you compare to compaction. Compaction is expulsion of air. For consolidation, there are expulsion of water from the void. Okay, look at here. This is the saturated soil. And then you have a load at the top of the soil, and here is ground level. So this is the soil before, and after you apply the steady pressure, so what happens is the water will go out from the saturated soil, okay, as known as the expulsion of water from void. Alright guys, look at the theory of consolidation. For example, this one is our house. So, this is the soil and ground level. So, the theory is, this theory of consolidation is happening when the load apply and the water squeeze out at the top and also bottom. Okay, so this one is odometer test. Okay, we have the porosities at the top and bottom, and then we apply load and the water will squeeze out, right? So look at this. This is the simple theory. Okay, for the first one, this one is the initial soil, and then when we apply 1 ton load, what happened is the water is squeezed out, right? And then when we apply more 4 ton to 5 ton load, the water is squeezed out more, and then the soil is shortened or settled, right? And then when you increase to 10 ton, we have more water squeezed out from the soil. And then after that, when we remove the load, okay, the soil is expand a little bit, right? So this is actually, if you see here, this is volume versus time. When you increase the load and then the time, right? So what happened is there will be settlement, right? The settlement increase. Okay, the volume versus load. Okay, when you increase the load, the soil gets stiffer. Okay. Alright, so look at this. This is happening when we unload. Okay, so settlement are partly recoverable. So we load and then we unload. So look at this, the volume and also loading here. This is the process of consolidation, referring to the spring analogy. Okay, this one is the Zaki's model. It is considered a simple model consisting of cylinder with spring at its center. Inside cross-sectional area of cylinder is equal to area meter square. A cylinder is filled with water and has frictionless water-tight piston and valve. Okay, so you look at this. This one we have three states. Okay, three different. Okay, so first is the original states. Okay, spring is analogous to soil mineral skeleton. Water represent the pore water pressure or pore water in the soil. Valve represent the pore size in the soil. Okay, the stress equation. Delta stress is equal to delta stress prime plus U, right? So where delta stress prime is 0, so delta U is 0, so delta stress is also 0. So because we have original state here. So when we add load or load is added, when a load is added on the piston, entire load will be taken by water. However, this one we close the valve. Okay, this is due to water incompressible, so no deformation in the spring. So excess hydrostatic stress delta U. So this is the stress equation. Delta stress is equal to delta stress prime plus delta U, where delta stress prime is equal to 0. So this one is 0, so means that delta stress is equal to delta U. Okay, this one, delta stress is equal to delta U for the case of load added but the valve is closed. And then when the valve is open, okay, when you open the valve, the water flow outward. Okay, the water flowing out. This reduction of the excess hydrostatic pressure and increase the compression of the spring, because we apply load and then we open the valve, so water will flowing out. So look at this, the stress equation. Delta stress is equal to delta stress prime plus delta U, where if delta stress prime is more than 0 and delta U is less than delta stress, thus delta stress is not equal to 0, right? So now we look at the reach equilibrium. So when you open the valve and you apply the load, and then after that, when the system reach equilibrium, no water will flow out because the water is considered is no water here. So excess hydrostatic pressure will become 0. Okay, because no more water. The stress fully taken by spring. Thus, soil pressure delta stress is equal to delta stress prime plus delta U. So U is equal to 0. So delta stress is equal to delta stress prime. So this is the spring analogy. Alright. Alright guys, during the normal compression, okay, so we have elastic and plastic deformation. So what is plastic and what is elastic? The word plastic and elastic actually this one is described the definition. Okay, so first we go for the plastic deformation. Okay, it's a process which permanent deformation is caused by a sufficient load. So meaning that when we apply load, and there will be a permanent deformation. Okay, it produces a permanent change in shape or size or solid body without fracture, resulting from the application of sustained stress beyond the elastic limit. Okay, it's more than elastic limit, so the shape or size of solid will be changed. Okay, all right. So for elastic deformation, when load is applied on a soil solid, it is deformed. When load is released, the soil solid return to the original size and shape. So it is said as experience elastic deformation. So different between plastic and elastic. For elastic, it will return to the original size or shape. For plastic, it will change the shape and size without fracture. Alright, so that is the difference. So for theory consolidation, the clay is saturated. We assume the clay is saturated. Drainage can only occur in vertical direction. Darcy law is valid for grain and soils. Okay, means that drainage can only occur in vertical direction at the top or bottom lah. And then solid particle and pop water are incompressible. Total stresses remain constant on any horizontal plane during consolidation. The clay does not expand laterally. Okay, this is the assumption theory of consolidation. Alright, now this is the odometer test. Okay, this is mechanism of odometer test, and this is your sample, and you have the porosity at the top and the bottom. The porosity function is to allow the water go out from the soil. Alright, so what we do is first we apply load. We apply load at the top and we compress. What happens is when you open a valve, the water squeeze out at the top and also from the bottom. Okay, so when the water is squeezed out, if you see here, there will be a settlement or the volume of the soil will be reduced. Okay, this is the YouTube link that you can refer how odometer test is conducted. Alright, this is odometer test apparatus. Okay, look at this. This is how this is the apply load, and then we have the mole here, and then you will you will have the reading here for the test, and then and then you may go to the lab, and also you can refer to the link just now if you want to know how we conduct the odometer test. Okay, just now you saw the apparatus for odometer test, and this is the odometer cell and accessories. Okay, you see the accessories here. So right now we look how we conduct the test. So this is the odometer apparatus sample. This is the accessories. Here we have the vernier caliper, and we have the all the accessories. Okay, this is soil sample. Okay, and then what you do is you trim the sample so that it will insert into the mold. Okay, for the odometer mold, then you trim the sample, and then what you do is you install the sample. You put the sample in the odometer test here, and then here is the sample, and then you put here the load. Then after that you will start the load. Okay, you apply the load at the top. Okay, the procedure is first saturated specimen is prepared. Okay, enclosed in a circular metal ring and sandwiched between porous stone. So means that we have the sample, and then you put the porous stone at the top and the bottom. Vertical static load increment are applied. So just now we apply the load. Okay, at regular time interval 12, 24, and 48 hours. The load is double with each increment up to required maximum. Okay, for example, 25, 50, 100, up to 800 kilopascal. During each stage, okay, thickness changes are recorded against time. So we record the thickness. Okay, and after full consolidation is reached under the load and the final load, the load are removed. Okay, in one or several stages to low nominal value close to zero. The specimen is allowed to swell, after which the specimen is removed. Thickness and water content is determined. So means that after you unload, just now if you remember, when you apply load, and you apply another load, and then after that you unload. So you have to wait and allow the sample to swell. Okay, with a porous stone both above and below the soil specimen, the drainage will be two-way. So when you apply two porous stone, so it's going to be two-way. It's open layer with drainage path length become height is divided by 2. The drainage is h over 2. If you are using one porous stone, the drainage will be different. Alright, so for consolidation, okay, we have fully consolidated, normally consolidated, and over consolidated. So what is the difference? Okay, a soil solid to be fully consolidated when its volume remain constant under a constant state of stress. We call it as the fully consolidated. For normal consolidated, the soil has never been subject to stresses greater than those presently existing. Okay, for over consolidated, the soil at some time in the past has subject to consolidating stress greater than present existing. Means that at the past, it going through greater consolidation process. Okay, when you compare to the existing. So this is the difference between fully, normally, and over consolidated. Okay, now we go for the settlement, because settlement is actually related to the consolidation. So you imagine like this. When we apply load on the soil mass, okay, when we apply load, of course, the load will compress the soil. And then the effect is the volume of the soil will be reduced. So, similar to under foundation load, the thickness are reduced and the settlement will occur. Okay, so what is the settlement? Settlement is the vertical downward displacement brought about by the process of consolidation. So, settlement occur by the process of consolidation. In coarse soil, this occur instantly or immediately as construction proceeds. However, for fine soil, the settlement may be very slow and continue after construction has finished. So it means that this is the long process. So that's why we have to determine the settlement after 10 years, 20 years, and 30 years. So we have to predict the settlement so that our construction building or construction or building not fail. Alright, this is the real world problem. So this one is learning Tower of Pisa. Okay, if you see here, there will be some movement here. The movement because of the settlement. Maybe the settlement at this part is increased. So means there are a lot of settlement here. That's why if we see there are some angle for the Tower of Pisa. Okay, this one is the Leaning Tower of Teluk Intan. Similar with the Pisa, there are some settlement here, so there will be a movement downward at one part of the tower. Here are the example of settlement. So we have three types of settlement. First is uniform settlement. So means that settlement is uniformly happen. Okay, so uniform at every point is uniform. For this one is no crack, but the house is dragged down in the soil. Alright, so this one is tipping settlement. Okay, this one is just tipping settlement. So this one is mostly without crack. So tipping because we have some angle and the settlement is not uniform for but you will see here this is quite similar to the angle. Okay, every part is settled. Okay, but it's not uniform. Okay, this one is differential settlement. Okay, differential settlement is quite dangerous because this one will come with the cracks because only settled at one point. Okay, if you compared to this one is settled at all point. Okay, this one is only one point, so this one is we call as a differential settlement, so it will come with crack. Okay, there are a type of settlement here. We see here this one is crack, right? This one is crack, so this one is actually differential settlement. Okay, some crack at the floor, can some crack at the wall. So alright, so cause of settlement, first is compaction. So particles are forced into closer or packed condition where air is expelled with the reduction of volume. And second is consolidation. The water is squeezed out, the pore water pressure is squeezed out from the saturated cohesive soil due to loading. So when consolidation happen, the settlement is also happen. Okay, so moisture movement occur in shrinkable or expansive clay with high liquid limit. Clay soil with will show a shrinkage or expansive condition due to decrease or increase of water volume. Alright, so loss of lateral support. The lateral support is highly important in cases whereby the site excavation conducted nearby at an adjacent building perhaps will induce the shift or bearing capacity of the existing building. So meaning that here if you have a new excavation conducted nearby the adjacent building, so building, it will affect the old building. Effect of vegetation associated with the high plastic clay when draining off water from the roots of the tree. The removal of the tree means that more water confined to the soil. This create the water to expand and swelling occurs. Okay, so this one is for high plastic clay. Okay, effect of groundwater lowering. Okay, the water table are lower due to pumping of water or during excavation. The settlement occur due to change of hydrostatic condition. Okay, this one effect of temperature changes is we have frost for the winter, okay, in silt and fine and chalky soils. Frost expansion for winter, it will be expansion provide open rubber field gap. For heat occur in clay, cause shrinkage. Okay, this is example. Effect of seepage and scoring. Scoring in the sandy soil, fine dry sand. Scoring is the removal of material by surface water and stream. Okay, and then piping, the loss of stability at bottom of excavation due to upward flow of water. Okay guys, now we go for the types of settlement. We have three types of settlement. First, it's immediate settlement. Second is primary consolidation settlement, and last one is secondary consolidation settlement. Okay, so for immediate settlement, this one is occur directly after application of load or during the construction without a change in moisture content of the soil. Okay, this one is due to elastic deformation of soil. The magnitude of the contact settlement will depend on the flexibility of foundation and the type material which it is resting. For example, if there are sand, usually this one we have immediate settlement. Okay, primary consolidation settlement, decrease in volume of saturated cohesive soil due to expulsion of pore water. Okay, alright, so number 3, secondary consolidation settlement is long-term decrease in volume due to plastic adjustment of soil fabric. Okay, alright guys, now we go for the soil stabilization method to avoid or to reduce the risk of settlement. Okay, in Malaysia, soft soil deposited are widespread all over country and mostly found in coastal area. Okay, for example, in Penang, in general, soft soil possesses low strength and high compressibility, thus having low bearing capacity. So, the soil need to be improved to avoid excessive settlement and prevent stability failure that affecting safety of the infrastructure. Okay, so one of the method, the effective method for the soil stabilization is preloading. Okay, this one is economical method to reduce settlement and improve the bearing capacity of soft soil. Okay, usually for the preloading method, it's usually combined with the vertical drain. Okay, because preloading is we apply the load. Okay, and then we have to squeeze out the water by using the vertical drain. Okay, so this is combination of preloading and vertical drain. Okay, preloading is surcharging the ground with a uniformly distributed surface load prior to the construction of the structure such as building, embankment, motorway, runway, highway. Alright, so the purpose is take up the settlement under the civil engineering structure before they are built. So means that we do the settlement first, okay, before the structure is built. Okay, soil suitable for preloading is compressible soft to medium soft saturated clay, silt and organic clay, and pits. Okay, for preloading, we can conduct the process with or without vertical drain. Okay, however, the result will be different. So preloading is usually accomplished by placing surcharge fields. Okay, so we apply this one is surcharge field. Okay, we load here and then we will have the slow draining subsurface. However, this one is without vertical drain. However, to accelerate the consolidation, Okay, vertical, usually vertical. Okay, vertical drain are often used with preloading. So when you apply the vertical drain and also the charge, the um, the process of consolidation will be faster, right? Okay, so vertical drain act as free draining water channel surrounded by thin filter jacket, which prevent the surrounding soil from entering the core. It will accelerate the rate of consolidation. So we have two types of vertical drains. First is sand drains and also sand wicks. Right, this is example of vertical drain here. Okay, example of vertical drain. This one is vertical drain. Wick drain is about 4 inch wide, 1/8 inch thick, which act as high permeability conduit for water to flow out of the soil and to the surface. So water will flow out from the soil to the surface. Most common application of wick drain is for accelerating the settlement rate of compressibility soil. So this one is to accelerate the consolidation process, right? Okay, sand drain is a simple process employing a column of at least 10 inch in width, okay, auger into ground to be surcharged and consolidate. Okay, we have the sand drain here. Okay, the column is then filled with the sand and connected to the free draining blanket of granular soil. This one we have sand here. Okay, that's what we call as the sand drain. Alright, so this one is different. This one is preload, and then here we apply the horizontal drain, water drainage. Okay, going up. So this is a combination of vertical drainage and horizontal drain. Alright, so this one is soil. Okay, so we want to improve the ground soil. We want to improve the soft soil. So what we do is we install the vertical drain here, and then we install the horizontal drain here at the top, and then we apply preload. So what happen is when we apply load, the water will compress and squeeze out. So to accelerate is the water here we go to the vertical drain, and then in the vertical drain the water will go out to the water drainage in the to the horizontal drain. So the water will go out from the horizontal drain. Okay, so this area, the ground is improved compared to this area, soft ground. Okay, when the load such as embankment act on soft ground, the ground settles. The time required for the completion of settlement is proportional to the square of drainage distance of the excess pore water in ground. Drain methods are ground improvement method which facilitate consolidation, settlement, and improvement of ground strength by shortening the drainage distance. Okay, we shorten the drainage distance, so we shorten the time to do the time to soil to consolidate, and to make sure that the settlement will be faster. Student, please don't ignore your own potential, and you never forget how capable you are. Good luck, guys.